Can you hear me? Can you hear my voice?
Yes, sir.
Okay. Okay. So in the last class, we discussed about the introduction part of the geology. Right. Yesterday in the afternoon session. So this class we are going to study the application of engineering geology in civil engineering practice. Okay. Let's start with the slides. Let me share the slides now for you guys. Could you please text your USN and your name in the text box, chat box, so that I can mark the attendance for you guys. Okay, and okay, right, right. So in the yesterday's class, we discussed the whole thing of internal structures, and so yesterday we discussed what do you call this? Okay, syllabus, complete syllabus. Let me share the screen now. Yeah. So as per the syllabus, let's start with the model 1. That's called application of geology in civil engineering practice. What are the applications of engineering geology in civil engineering practice? Okay. So can you see the slides now? Anybody can confirm?
Yes, sir.
Okay.
Yes, sir.
Right. So as you see the slides, first slides, you can see the applications here. Especially this slide is related to the mineral exploration and mining part. Okay, so for a geologist, so mineral exploration and prospecting, and then going for the drilling and for the mining activities and exploitation of minerals, valuable minerals, maybe iron ore, gold, tin, tantalum, copper, lead, zinc, many more minerals. Let's go for the second. What is geology? My voice is audible? Hello? Voice is audible?
Yes, sir.
Okay.
Yes, sir.
So
Yes, sir.
it's a branch of natural science. It's a study of Earth. Okay, and for studying the Earth with the detail of petrology, structural geology, mineralogy, mining geology, economic geology, and civil engineering geology. Okay, and even in stratigraphy. The stratigraphy. I would like to show the chart for you guys. Okay, and photogeology. Photogeology is nothing but it's a remote sensing. Okay, remotely collecting the information. That's called a photogeology. How we are going to take the photograph by that's it's completely involved with the let's call the physics. Okay, without physical contact, you are capturing the information. You are taking the photographs. That's called a photogeology. That's called your remote sensing. Okay, this is how the capturing this the Earth surface pictures from the satellites. Okay, so as I told you that yesterday we discussed about what is a petrology. Okay, these are all the main branches in engineering geologies. One is the petrology. This is a study of rocks. Okay, because it's a new subject, you guys, and you carefully read the contents. Okay, I'll share this what I call this PPTs, and even for the video of this link in the Google Classrooms. Once I finish this class, I used to I will upload this video link into the Google Classrooms. You can go through the link and you can see the things. And even I will upload this PPT also in the Google Classrooms. All the notes and everything we are going to upload into the Google Classrooms. You can download the things and you can start reading the contents, the notes. Okay, so petrology. So petrology means it's the study of rocks. Why you require to why do you need to study the petrology? To understand the different rocks. Okay, for detailed part we'll go in the later stage. It's a structural geology, that is also we discussed in the last class. So structures, so folds, faults, joints, unconformities in the rocks itself. Okay, that we are going to study. Mineralogy is the study of minerals, different minerals. In the world there are more than 2000 minerals are identified with a name. There are many more minerals are still lying there. Need to identify, naming that properly. So geology, mining geology, where when the mining is going happening there, we are going to study the what is going on in the mines area. What is the geology? What type of rock? What type of minerals are there? What is the structures are there? How, which side is the depend? Okay, so economic geology. Okay, this is purely on economics. It's a valuable minerals which we are going to extract from the mines. Okay, all the minerals we are not going to mine it. We are going to mine the minerals which is valuable, which is a high concentrate. Okay, that mineral only we are going to mine it. Okay, otherwise we cannot run the mines because of it may be comes under the loss. So and stratigraphy, it's this from the beginning of the till date, different stratigraphies. I will show you the chart so that you can easily understand the things, how the what you call in 4.5 million years back to the recent. What are the Jurassic, uh, Jurassic age to the till date, and it's a physical geology and hydrology. Hydrology is nothing but that's called even water resource management. Hydrogeology. Hydro means water. Okay, study of water resource management. Maybe a micro watershed, major watershed, or it may be a any other the irrigation. All those things comes under the hydrogeologies. Okay, so what's on that? Okay, what are the applications in geology? The first part is that a mapping. That's the first application of in the earth science is the mapping. Okay, so the engineering geologist, generally the geologist has to prepare the geological map by doing the survey in the specific areas. They are going to uh, note down the what are the different rocks are there on the exposure on the surface of the earth. They will take out some samples for the further analysis. Okay, and aerial photographs, we use the aerial photographs during the mapping of the area. Say for example, anybody, maybe somebody has seen the Sandur Ballari sector. Okay, that's a completely iron ore mines. Where is the high grade of iron ore mine? Iron ore mineral is there. What are the iron ore minerals? Hematite, magnetite, goethite, and limonite. Those things. Majorly, we are extracting the mineral that's called hematite. Okay, and even in magnetite also. But in Ballari sectors, maximum you can get that's called hematite ore. Okay, from Sandur to Hospet sector, there are like horseshoe belt. Horseshoe means a U-shaped. The hills are running there in the from Hospet to Ballari sector, Hospet to Sandur. You can see in the Google Earth, it's clearly visible, and you can see all the mines also, how they were working there. So this is how the geologist mapping part. Generally, the geologist is taking the traverse, walking around the area, specific area, preparing the geological maps. What is there in the geological maps? There is a different rock types. There will be a what you call which side is a dipping structures also, folds, faults, joints, and unconformities. Okay, if it is there in that, and different soil types, and if it is there in the what you call in the old working mines in the specific areas, that is also we are going to map it. Whatever you are going to observe on the surface of the earth, which will map it now down the field itself, and we'll bring it to the in the office, and we'll do the interpretation part, and we'll prepare the detailed geological map of that. That includes the different rock types, different even if you get the in between specific areas, maybe a small streams, or it may be a big river. That is also we are going to map it. For this purpose, the earth science is very helpful for geologists. The whatever the minerals so far we discovered in the world, the geologist has discovered all the minerals, and the mining engineer will come to the next part. Once proved that there is enough resources, say for example 100 million tons of iron ore. So for that takes minimum 5 to 6 years. Minimum 5 to 6 years it required to prove it, because it takes time. First 3 years for explorations, prospecting and exploration. That is the early stage of explorations. Then after that, another 3 years. There are 3 types of the license. You will get it from the government. That government is from the it's called Indian Bureau of Mines, IBM. It is not software one. It is the mineral sectors. There are different departments which controls the exploration and mining in the India. Let's say it's the first one is Geological Survey of India, GSI. Geological Survey of India is the first organization in India exploring almost all the minerals, each and every corner of India. If you go to the Geological Survey of India, it is there in the Dayanand Sagar College, nearby Dayanand Sagar College, in the city itself. Next to that, there is a Geological Survey of India. Okay, and every state there is a main head office in the capital cities and sub office in the district levels. Okay, so the Geological Survey of India surveyed almost all the mineral sectors, each and every corner of the India. Okay, they have identified the minerals, whether it is occurrence, whether it is a good deposit, whether it is high potential zones, everything they have mapped it. Then the private people they are going to take the lease for that particular areas from the government. Okay, that is going to sanction from the Indian Bureau of Mines. That's a central government organizations. Okay, they are going to give the first license is a prospecting license. That's for 2 years. Then exploration, that's for another 3 years. Based on the results, 2 years working results, they will grant for another 3 years of prospecting license. In that, so you are going to do the mapping and drilling also. As I told you that, it's the first slide. This is a geophysical survey you can carry it out. Geological survey in the ground you can carry it out. You are going to analyze all the maps, okay, the drawings, everything. This is only the surface indications of the minerals. Okay, so to want to understand the subsurface of the minerals behavior, how it is mineralized, that we need to do it by drilling. While drilling, we need to extract this core. We need to extract the core like this, and it's called 1 meter. Okay, 5 meter box will be there, and each one you can analyze it for further. So at what depth? There is only the soil is there, and to what depth is a hard rock. Is a hard rock. Is there in mineralized zones? Okay, and strength of the rocks, rock quality designation, everything we are going to analyze it. Mineralogical analysis, chemical analysis, and strength of the rock also we are going to analyze it. Based on this analysis results, we are going to prepare the mining plan. So mining plan, that that involves your environmental protection management plan, environmental impact assessment, EMP also. Okay, and yeah, here we are. Yes, it's in the mapping part. Okay, this is how the things. The next part is the exploration. As I told you that after this we are going for the explorations, and for explorations it takes 3 to 5 years, and after that pre-feasibility report we are going to prepare based on this the core results. We are going to analyze it, what are the minerals assemblages in the rocks, and uh, what is the strength of the rock. Everything we are going to analyze it. Okay, up to what depth the hard rock, and towards the soft rock, whether it's a mineralized zone, how much depth is there, how much waste we need to extract, remove from the earth. So how much ore you can get it if you remove the uh, ore burden. Everything we need to calculate. That mining plan should be for 20 years. They are going to sanction for 20 years, and they are going to renew it. Okay, that's it. It's a mapping and exploration part and project planning. Project planning is the most important aspect in the. Okay, so then it comes to surface water. So sources. Water is essential for human lives. Okay, no water, no life. Some extent you can survive, but some extent you can survive, but it's very difficult. You need a water for drinking purpose, for domestic, for industrial purpose. Okay, right. So it's a precious. Okay, so geologists generally used to identify the groundwater potential zones. So if there is a good heavy rainfall, there is no problems. Say for example, in the Western Ghats, there is heavy rains. There is no problem for the groundwater and even for the surface water. But when you go to the, and when you come to the northern part of Karnataka, some extent dry areas. Most of the time you'll not get the water. After Ranebennur or Dharwad areas, it's very difficult to get the waters. When it comes to the Shimoga, Chikmagalur, Eastern districts, you'll get the sufficient water. But since 3 4 years, there is a very good rain. All the ponds and all the surface water bodies are the very full, and if there is a good surface water, there is no problem with the groundwater. So it will percolate into the subsurface and reaches to the groundwater zones. Okay, then you are going to drill it and you are going to extract. That's a groundwater explorations. Okay, that is depends on the both volume of total runoff, drainage basins characteristics in the surface water, and sedimentary process in the basins, weathered areas, silting potential zones, and erosion potential zones on the estimated. Okay, planning in the hydraulic structures in the basins. This is called the surface water. Groundwater is the major problem in the majority of the areas. Okay, where is the groundwater occurrence, how we are going to identify this by scientific method. I think yesterday I told you this, how we are going to identify the groundwater zones by doing the geophysical survey. That's called resistivity method. By deploying the resistivity meter, we are going to assess that subsurface strata, whether it's a hard rock, soft rock, medium rock, or it may be the highly weathered zones, right? Based on that, we are going to assess this. Yes, up to at 50 feet depth, or maybe a 200 feet depth, there will be a water. The water zone will be there. It may be a dry zone, or it may be a wet zone. We don't know. That's very good. That's very difficult to assess it. This is only the just what we call what it says indirect method. It's not a direct method. Direct method in the sense you're going to drill it, you're going to get the water. That's a direct method. Same thing happened for our mineral exploration part. We are going to assess the surface. We are going to take out the soil sample, water sample, rock chip samples. Based on those results, we are going to assess the subsurface geology, subsurface what we call mineralization zone. It may be there, not exactly the 100%. It may be there, 80% or 70%. You can guess it based on the field experience. You can assess it. So the 100% truth, when it comes, it is when you drill it, when you take out the core, when you are going to analyze it. Physical, the logging, you can do it. Yes, this is a color and this type of color, and from this depth to this depth. So if, for example, 0 to 10 meter, there is a weathered soil. Then 10 to 100 meter, there is a highly weathered zones. Okay, 100 to 400 meter, very hard rock. When you drill it, when you take out the core, then only you can assess it. That is called a direct methods. Okay, that's the one. And for slope stability and geological parameters are possible for slides. Say, for example, slope stability, when it comes to that, recently had been, you have seen in the, what you call in the Madikeri, in the Western Ghats, especially in the Western Ghats, including in the Madikeri and all, there is a heavy rain. And most of the hills are collapsing, especially in the roadside, not in the interior one, where they did the road cuttings, and the human activities are happening there. Okay, and there is a lot of fractured zones in the rock. That's a one thing. If it's a very hard rock, must be in the very some noise is coming. Okay, hello, so voice is audible. That's
Yes, sir.
Yes, sir.
okay, right. So here, yeah, okay, in the Madikeri and the Western Ghats, you can see that why the landslides are happening there. That's because of there may be a lot of the fractured zones in the rocks, or it may be a highly weathered zones due to heavy rain. It's not going to tolerate the things, and it's generally going to erode it. It happens. But why it was not happened before this? Since many years, this has not happened. That's a question mark. But still, I would say there was a stability, or I would say it is there was no much road construction, or it may be agriculture, or it may be nothing is happening there on the top of the hill. But nowadays, almost all the hills are covered with the agriculture people. Most of the times, I would say it is. So there may be a road, there may be the trench may be there, did the trenching. So due to heavy rain, it may start erosion. It may start the erosion of the topsoil. Then it will start with the small amount of water because of the slope. So it may so more. That is the thing. The slope stability also we need to carry out. That depends on the rocks. What type of rocks is there that we need to study. Then comes to the geological structures. Okay, field investigations. Generally, we used to identify the what type of structures. Say, for example, dip, strike, folds, faults, joints, unconformities. Unconformities is very difficult to identify in the surface areas, but folds, faults, joints, you can see easily. Okay, you can see easily. Okay, those things we need to study it in the engineering geology, especially in the applications of engineering geology. So when it comes to the tunneling, maybe you have seen in the Bangalore metro. That's the best one you can give the example. Bangalore metro, there is a underground. I mean, I would say it's a tunneling. They did the tunneling and they made it for the metro work. Right, the tunnel site is selected based on the detailed study of the structures, different rock types. And if they drill it first, maybe I'm not sure how they are going to drill. Maybe they may drill for small holes and to identify the subsurface, what you call the stratus. Generally, this they will do it for in the flyovers. If they want to drill it, I mean to erect the pillar, they will drill it first, some extent, and they will that's a preliminary investigation. That's a preliminary investigation. They will drill it, and they will note down the up to what depth. Okay, 10 feet or 20 feet, there is a soil, and below that there is a hard rock. Okay, and below the 30 feet there will be again some fractured zones. Based on that, you are going to assess that. Okay, up to what depth I can fix the pillar. Okay, below that 50 meters, completely hard rock, 30 to 50 meter hard rocks. Once you encounter the hard rocks, especially in the Bangalore zone, it will be completely hard rocks because it's a granite zone. It's a, the hard rock terrain. So completely covered with the igneous rocks. Okay, no doubt. But where there is a sedimentary rocks are there is a chances of lot of problems, risk will be there. Okay, because most of the structures are the geological structures, it may be folds, fault joints and unconformities. Those things are happen in sedimentary rocks. Okay, so tunneling, we need to take care of this. That's one. And even for our flyovers, fixing the pillars, erecting the pillars, before that we are going to do the small the drilling part to test the subsurface strata, subsurface profile, soil profile. Okay, so then they are going to do the excavation part. Those small, making the small drilling hole and collecting information, it is not that much of expensive. Then you are going to directly do the excavation part. Excavation part is expensive. Okay, that we have to do it, but for budget calculations this is required. Okay, if you get the once you get the different strata thickness, if you get the very hard rock at a shallow depth 5 meter, you need to drill it. Sorry, you are going to do the small type of the blastings. Okay, for that there is again cost is involving. All the things we need to keep it in mind, and we have to do the budget. Okay, as I told you in the last class, time for any task for doing the tunneling, how many kilometers you are going to do that. That's the first part. That's your task. Then what is the budget you required for that? Then what is the time deadline for that task, time and budget? Okay, for all these things you need the preliminary investigations. Okay, that's how what I am first in the detailed study in the tunnelings. Then when it comes to the earthquake, so the seismic nature of the project sites. So when you are going to construct a dam, it's a big project like a dam or reservoir, those areas you need to take care of the seismic zones, seismic nature of the areas, whether it is active or it's not active. If it happens, when it happens, the earthquake and all those, the background history you need to study it. So the seismic things, that's called earthquake. Okay, seismic zone mapping of the country is happened and it's done everywhere. It's almost all the country, each and every part of the India. Okay, but we need to, when you are going to identify the dam locations, you need to incorporate this. Okay, that is a one thing. And evaluate the active and inactive fault zones. That's the most important. See, the fault zones is always active because fault is nothing but a fracture with the displacement of the the blocks, or it may be a formation, or it may be the what you call I would say it's a rock movement, the blocks. So faults, there is a major difference in the faults and fractures. Okay, faults and joints. Joint is nothing but crack, it will be there, but still that is also very risky one. But fault is there is a movement. Okay, that is why you need to take care of for the any dam construction areas. You need to take the seismic nature of the project completely areas, and you need to take care of the active and inactive of the fault zones. Okay, keep the historical record. As I told you, that historical record means it's already surveyed which area is active, which area is not active, inactive areas of the earthquakes. That we need to collect the data from the valid source. Okay, then you go for the okay. These are all the engineering, engineering geology, the applications in civil engineering projects. Okay, and generally in your projects, I would say it is a maybe a dam construction, or it may be in the tunnel construction, or it may be in the reservoir, or maybe a road, or it may be a highways, or it may be in the metro constructions. almost all your projects are community related. I mean, your contact with the local people. Okay. And even if you are going to make the layout plan, that is community related. The best example I would give that, that's called the dam construction. When you are going to construct a dam, you are going to study the water resource management. You are going to study the catchment areas, the drainage basins of that particular areas, and you are going to locate the best ideal place for dam construction place. For that, how much height of the dam, how much depth of the dam, how much water is going to accumulate on the particular areas, and the backwaters, how many villages are going to submerge, how many the agriculture land is going to submerge if you construct a dam. Okay, and there will be a local, maybe a more than 10 to 20, more than 10 villages are going to, depends on your height of the dams, the backwater will be calculated. How much, then you need to calculate that. How many the agricultural land is going to submerge and the villages are going to submerge, and then you have to give the compensation, one thing, and then you are going to give the other place, shifting the villages, and you need to acquire the land. There's so many complications. That's why I told you that this almost all your projects are community related. It's all society. The best contribution you are giving is the from the civil engineers. Almost all the time you are with the community people. Okay, if you take the small example, if you are going to construct a house in Bangalore, okay, that is nearby house next to your plots, there will be a lot of issues that you need to sort out, then you start your buildings. This is how the things. Let me show you some of the picture. It's what I would change all of these for this. So that you can have the okay, how the mining is going to happen there. Okay, it's the best production sites and MWE Academy. How the gold mining is happening there, and how the gold deposits are there. This is a secondary gold deposit, not a primary one. Okay, primary one is somewhere in the hard rock. Okay, from the hard rock, it is started erosion, weathering, erosion, and transported and deposited all along the river bed. That is the story of this. Okay, and here you can see this. Can you see the video? Hello?
Yes, sir. Yes, sir.
Okay,
Yes,
okay,
sir.
okay,
Yes,
okay,
sir.
okay. The part is that why I'm showing this video is that so here this is a okay, let me come this. This is a topsoil. Okay, nothing is there. This is not a ore zone, it's a waste. It's topsoil. This is called overburden. Above the ore, whatever it is there, that is for a waste for us, that's called a overburden. Okay, so here there's a black colors, grayish black colors, that you can see this layer. This may be hardly 1 meter. Okay, above that, this may be the 5 to 6 meter height, 6 to 7 meter height. Okay, so this is a waste for us, and this is a ore zone. It's a very good potential of ore zones. This is actually deposited very long, maybe more than 100 or 200 years back. It's not a recent one, but still we are in geological point of view, we can say it's a recent one. Okay, so this is a one, and downside there is a village, the river is flowing there, and next to that river bank, it's flowing there. You can see the water. So water is encountering there in this part. Okay. This is secondary gold deposit, secondary minerals deposits, and which you are going to mine it here. This is complete the ore zone, which you are going to process it. When it comes to the hard rock, we need to crush it. We need to, when it comes to the hard rock, we need to crush it. First, we need to drill it, blast it, and we need to transport to the crusher. Then there will be a primary crusher, secondary crusher, tertiary crusher. Then will be a grinding. Then we are going to do the smelting part, right? So in this case, it's not like that. It's already naturally processed one. It's already happened the weathering part naturally, and weathering, transportation, deposition in the lowland areas. It's a naturally processed. Okay, just we need to wash it. It's a sand with the clay materials. It's a sand with the clay materials and with the gravels. Okay, that's all. If you put the water, it will, the lighter material will go out and the heavier material will be there. Okay. Okay. This is what they are going to put it in the, scrubber plant in the hopper. Yes. Best place. Okay, and this is a very thick forest, and did the road and for the further expansion of the project. Okay, and next to that, don't want to show this and remove the part. This is how generally. Okay, can you see the river here? Downside, yeah. You can see the river. That is a river. Next to that river bank, this gold deposit is happening there. Okay, from here 35-kilometer backside upstream side, there is a called one big hill where there is a primary gold deposit there in the hard rock. Okay, so from there it is weathering, transportation, and deposition all along the river bank. From the main river, it's about maybe 300 to 400 meters, 300 to 400 meters on either side of the river bank, you can get the gold deposits. It's not deposits in all over the place in the same condition. No, in some places it may be only in the river. Some places it may be in the 50 meter on both sides of the river, and some places it may be a 200 or 300 meter on either side of the river. Okay, it depends on the conditions. Okay, and let me show you the actual how it is going to crushing. Can you see this? So from the mine site, the excavation part, they are going to put it in the hopper, and there is a grizzling here in front there to liquefy the material. Okay, and in center part there is a this here is a motor, and here is a water source, and from here in the drum inside this there is a grizzling, the pipe is there, it liquefied the water, and it's washing just like a washing. Okay, and here the mesh is that they fix the mesh for this trommel, and they are going to oversized material is going down here and outside, and the subsurface material, I mean subgrinds, means less than some Okay, they are going to get into this channel. This is called your sluice. We call it as a sluice. I'll show you that sluice part. Okay, so here This is a very short distance. Actually, it should be the longer one. It should be go very slow. Otherwise, it cannot hold. It cannot catch the heavier minerals. Say, for example, gold is 19.3. Okay, the gravity, specific gravity, the bulk density. So here, the gold is going to settle down at this place in the channel, and rest of the sandy materials and the clay materials washed into the tilings. Okay, oversized material is going out here. Okay, can you see this here? You see this, they fix the mesh here for based on the this mesh is based on your grain sizes. Different grain sizes, different mesh they are going to fix this. And you can see this, the oversized material is going down here outside. This is how we are going to process the minerals. Okay. And they're going to remove this, and down below that, okay. Okay, I've seen the ore washing plant here. Can you hear my voice? Hello, Chiranjeevi?
Yes, sir. Yes,
You can hear the voice. Okay, so this is the tilings. That means the waste. I should actually, technically, if I speak, so this should not be the way of doing the processing. Okay, and the tiling should be somewhere in the tiling pond. This should not be exposed into the river. Okay, of course, it is not a chemical washing. It's a water wash only. But still, if you want to recover some minerals here from this tilings, because tilings still have some minerals, it's not a waste. It may be a low grade. Okay, it may not catch in your that's called in this slot. What you call this? This we call it as a sluice. Okay, we may not recover it here. It may go escape and lie down here in the down below the sludge. Okay, this we need to keep it in separate pond. Then if you analyze take out the samples and process it and test it. If you get it again, you process the same material there. So this is how secondary gold mineral deposit processing. Okay, secondary means from the primary, it's weathering, transportation, and deposits. So only the travel mode is the water. Okay, otherwise no other the mode of transportation will not be happen. Okay, this is only happen in a gold, diamond, tin, tantalum. Okay, not in the iron ore. Iron ore is not much happening like this. Okay, gold, because even if it happens also, the grade will not be there. Those are the bulk commodities, like call this I would say it's iron ore, limestone, bauxite, and these are all bulk commodities, huge quantities. So even if you get in a small quantity, you cannot mine it. Okay, but in gold is not like that. Even if you get a small quantity, also it's worth for doing the mining, because 10 gram of gold is 50,000, isn't it? Hello.
Yes, sir.
10 gram of gold is how much is nowadays? 50,000 in a marketplace.
52.
It's a huge, highly valuable. Okay, so let's stop now today's as of now. It's 9:30. So we'll continue in the next sessions. Okay. Okay, let's stop the videos first now. Okay. Thank you very much, sir. Thank you, and see you in the next sessions. That may be in the afternoon session, right? fifth hour. That's the basics, right? Okay, thank you very much. Okay, thank you.